Okay, let's read this question. Given with the circuit, okay, fine, good. So what is in the question? In the interconnection of ideal sources shown in the figure. These are all ideal sources. This current source, voltage source, whatever it is. It is known that the 60 volt source is absorbing power. Where is 60 volt? 60 volt is here. So this source is absorbing power. Okay, what is the difference between absorbing power and delivering power? Let's first be clear with that. If an element is delivering power, most of the cases whenever we have a voltage source, one voltage source, some V value in a circuit with some element, this voltage source is responsible for delivering the power to this elements. Whatever the n number of elements in this circuit will be delivering the power. So from where the current is coming, the power that is delivered by this voltage source is going to give the power to the circuit or the elements here. So let's have these two elements alone in the circuit and see. So whenever the current flows through a resistive element, we know there's a voltage drop, plus and a minus. All right, so when you write the equation and the current is flowing through this element, right? So the current is flowing upwards like this. So when I write my KVL, as the current goes through this element, I see there is no voltage drop. It's not ending with a negative sign, it's ending with a positive sign indicating there is no voltage drop, but there is a power that is delivered to the circuit. It's not absorbing, it's delivered. So this voltage source is a power delivering source. Okay, so that's what it indicates. Whenever the current enters through that element, there will be a voltage gain. It's not a drop, it's like a voltage gain. It's with the plus. So we say V is a positive V, the voltage value is positive. But when it goes to a resistive element, we say there's a drop. Yes, because this resistor is utilizing the power. So what happens is this resistor becomes the absorbing element. It's not a source, it's an absorbing element, and this voltage source becomes the power delivering element. So this is a deliverer. So this is delivering power while this is absorbing power. So what I say, V minus the voltage drop across this resistor, let me call it as BR, equal to 0. So every time when the current goes through a powered absorbing element, there is a drop. That's why we have a minus sign. So whenever the current enters through a power delivering element, there is a voltage gain, or it's going to give something. So this is the total source for this whole circuit. So there is a plus, right? The plus V. This V is positive. Okay, this is a general thing that I wanted to make few people clear. That's okay. If you're clear, that's well and good. If you're clear already, that's well and good. Okay, fine. So now what we are given, the 60 volt source is absorbing power. That means what it is, whenever the current is flowing through this element, there's going to be a voltage drop. There's going to be some power utilized by this. It's going to absorb the power. So there are three other elements. These three other elements is going to give you some, it's going to deliver the power, while this 60 volts is going to absorb some of the power through. It's going to act like a resistor. It's not a resistor, but it's going to act like its behavior is like absorbing. Okay, all right. So what happens, this branch, I call this as a branch because there's no current dividing from this all the way. I'm marked the pink color, right? The same current will be flowing. These are all the series path for this. Okay, that means what, this 12 ampere current will be flowing all the way up, right? 12 ampere current will be flowing all the way up. Okay, so 12 amperes is the current that is in this branch. All right, so because this is the direction that is mentioned here in by the source, I'm using the same direction here as well. Okay, so so it's going to go enter this node. But what we said just now, the 60 volt is a absorbing element. That means what, when the current enters through this element, there should be a drop. So that if I mark the current direction like this, can I say it's going to have a drop? Yes, the plus and the minus. The current enters, it's having a plus and a minus, so there's going to be a drop. So this is the right direction. Suppose in case if I am going to mark it upwards like this, what happens? Then my direction is wrong. Why? Because the current is going upwards. At that time, the current goes and it ends with a positive sign, right? It goes out with a positive sign. That means what? It acts as a delivering element. So this is not the way to assume the direction for an absorbing element. This pink color is correct. Okay, because as the current flows down, there's a voltage absorb. It's like a drop, like plus and a minus. All right. So this is a way, that is fine. And we already know the direction here. It's this way, this current source, because this current source is pointed downwards. Okay, and this is I. And let's call this value to be Ix. The current that is coming down through 60 volt, let me call it as Ix. Okay, now let's write the equation for this node V. Okay, what is the current equation for this node B? The entering current is 12 amperes. Okay, for that node, 12 amperes current is entering, which is equal to the leaving currents. What are the leaving currents here? The current I and Ix are the leaving currents. And what are we supposed to find? We're supposed to find what is the current I. Okay, we have two unknown variables here. Even though we know we know this I and the 60 volts are in parallel, because there's no other element in between them connected. So 60 volt and I are in parallel. Same, it's connected. Both ends are connected together. 60 volts and this. Okay, they're parallel. So what I can say, this I will have the voltage drop of 60 volts. That's fine. The voltage of this voltage across this I current source will be 60 volts. Even though I know that I cannot, it's not a resistive element like that I can find the voltage drop directly. It's a current source. I cannot find the voltage drop directly. So in this question, we have dealing with we're dealing with ideal sources. So we cannot directly find we don't have the resistance for this ideal sources. So we can't directly get the value of the currents, and there are two currents, so two variables and only one equation. It's not possible. Okay, so we have to go with assumption method. Okay, let's try that. So we are clear till here, right? 12 equal to I plus Ix, and what we're supposed to find is supposed to find I. So what will be I? So if I rearrange this equation, I will be equal to 12 minus Ix. Till this it's fine, right? Okay, so from here we can say something. Okay, let me just put this, because this is where our answer lies. Okay, so here what I can say is this I equal to 12 minus 12 minus Ix. So this I should be obviously less than 12 volts. This we can say. So is there any option that is less than 12 volts? Yes. So 10 amperes is the only option that is less than 12 volts. So that could be the only answer that we can choose here, because it's a 12 minus of some current, because the current flowing through this is an absorbing current. It's going to be lesser than 12. So that's why we got this current direction correctly assumed, and this assumption is correct. Why? Because we know it's absorbing power. That clue told us this should be the direction of the current that should be flowing through the 60 volt. Okay, so should be less than 12 volts, so we choose option A. I mean, the option that's less than 12 volts is only 10 volts, and we go for it. Okay, thank you.